Today we're going to cover a couple of topics. The first one is simplifying higher degree radicals, and the other is adding and subtracting roots and radicals. So let's just start again by kind of talking about the fact that this is actually called a radical symbol. We talk about it as a square root because that's the only thing we've really known up to this point. But sometimes you can put a number right here, and that number is called the index number. And so far, when we would see it, we would say, oh, square root 4, because there's an understood 2 right here. But now we're going to change it and have stuff like cube root of a number, or fourth root of a number, or fifth root of a number. So that index number can change, and so can the number inside, which we're going to call the radicand. So let's just start here by simplifying a few. Some of these will be things you already know, and some of it will be new. So let's start here. First example. The square root of 125. So the square root 125, I'm looking for numbers that are perfect squares under the radical. So I want to try to break this number 125 into prime numbers and perfect squares. And we've already been doing this some. 125 would break up to 5 times 25. And I'm going to keep both of these numbers because 5 is a prime number and 25 is a perfect square. And since this is a square root, a perfect square is a good thing to have. So I have the square root of 5 times 25. And I know that the square root of 25 is 5, so I'm going to cross it off and put a 5 on the outside. So my answer would be 5 square root 5. Here's the second example. So this is where we're going to change it up. This time I'm going to have the fourth root of 810. So this time, instead of perfect squares, I want to look for a number that's a perfect fourth. That means it's something times itself 4 times. And those are harder to know off the top of your head. So I'm going to do a factor tree, and I'm going to try to break this up until I can come up with 4 of the same number. So just to start off, by looking at this, I can tell that this is 81 times 10. And that will break apart again to 9 times 9 and 2 times 5. 2 and 5 are both prime numbers, so I'm going to keep those. 9 goes to 3 and 3, and 3 and 3. And what I notice here is I have 4 of the same number, so I'm going to keep that number. So inside my radical symbol, I'm going to have the fourth root of 2 times 5 times 3 times 3 times 3 times 3. So that's what I ended up with here. So since this is a fourth root, I'm looking for 4 of the same number to bring something out of the radical. So since there's 4 3s, I'm going to cross that off and put 1 3 on the outside. And since there's not 4 of anything else under the radical, I'm going to multiply those numbers back together. So my answer would be 3 fourth roots of 10. Okay, let's go to the third example. The cube root of negative 40. So earlier, when we would have a negative number under a radical, we would say that this is an imaginary number. But that's not the case this time because I'm not doing a square root anymore. I'm doing a cube root. So I'm thinking of 3 numbers that multiply together that give me negative 40. So let's think about that. 40 is 8 times 5. I'm going to keep 5 because it's a prime number. 40 is 8 is 2 times 4. I'm going to keep the 2. And this is 2 times 2. And some of you may already know shortcuts to this, and that's fine. So I've got the cube root of, and now this is negative, so I have to have a negative here. 2 times 2 times 2 times 5. Well, anytime that your answer is negative, the number is negative, that means that inside here, there has to be an odd number of negatives. Either one of these numbers could be negative, or it could be that I had -2, -2, -2, and +5. Any amount of odd negatives produces a negative number. So when this is odd and the number inside here is negative, we know that our answer is going to be negative because I could have made all three of these -2. So my answer then, I have 3 -2s, so that's going to put a -2 on the outside. And it's going to leave me a 5 on the inside. So the rule here is if this is odd and the answer inside here, the radicand, is negative, you're going to pull a negative out from under the radical. We don't want to leave the negative under the radical. Let's do another one like that. Let's do cube root of -1250. So because this is odd and because this is negative, I automatically know that I'm going to have a negative answer. And then I'm going to try to break apart 1250. I know that 1250 is 125 times 10. And 125 is 5 times 25. And this is 5 times 5. This is 2 times 5. So I have cube root of 2 times 5 times 5 times 5 times 5. But because it's a cube root, I'm looking for a group of 3. So I have a group of 3 5s, so that's going to cross off and put a 5 in the front here. So I'm going to have -5 cube roots of whatever's left. 2 times 5, which is 10. What if this was a positive 1250? So let's go back up here at the top. If it was a positive 1250, then my answer is going to be positive. Before we had -5 cube roots of 10, but now it's just going to be positive 5 cube roots of 10. If it's positive in here and this is odd, our answer is positive. If it's negative in here, then our answer is negative. Okay, let's switch this up a little bit and put some variables under this. So let's go cube root of 125y to the 6th. So I'm looking for things that happen in groups of 3. And I've already done 125 a few times, so I know off the top of my head that 125 is 5 times 5 times 5. And now I've got to think about y to the 6th. This is y 6 times. I'm looking for groups of 3 because this is cube root. So I have a group of 3 5s, which is going to put a 5 on the outside. I have a group of 3 y's, so that puts a y out here. I have another group of 3 y's, so that's going to put another y on the outside. So instead of y on the outside, I have y squared. Notice there's nothing left on the inside. Everything canceled out, so my answer would just be 5y squared. So some of you probably kind of see a shortcut. How many times does a cube fit into y to the 6th? 2 times. Here's the next example of that. The cube root of 192z to the 10th. So let's think about 192. 192 breaks apart to 2 times 96. And 96 is 2 times 48. 48 is 4 times 12. 4 is 2 times 2. See here, 12 is 2 and 6, which is 2 and 3. So let's see what I've got here. The cube root of, I've got 1, 2, 3, 4, 5, 6 2's. I'm going to write it like that. And then I have a 3. So I'm looking for how many groups of 3 do I have in 6? How many groups of 3 would there be in 2 to the 6th? Well, that would be 2 to the 3rd and 2 to the 3rd. So I have 2 groups of 3 and 2 to the 6th. That's going to bring 2 2's on the outside. Leaves a 3 on the inside. And then how many groups of 3 would go into 10? That would be 3 groups of 3 with 1 z left over. So my answer would be 4z cubed, cube roots of 3z. Last example. Square root of 16 g to the 4th, h to the 5th, z to the 9th. So this is a square root, so there's an understood 2 right here. I'm looking for groups of 2. I know what the square root of 16 is. The square root of 16 is 4. How many groups of 2 would be in g to the 4th? There would be 2 of those. How many groups of 2 would be in h to the 5th? There would be 2 groups, but then I would also have 1 h left over. I better put my, and then 2 goes into 9 4 times with 1 z left over to make it 9.